So, why are we going to Mars? Why are we going to Jezero? And socket. Around 3.5 billion years ago, Mars, as far as we understand it, was like a primordial Earth. So it was wetter than it is today. Right now it's very dry. The atmosphere was thicker than the thin atmosphere that's there today. And as far as we understand it, there was bacterial life on Earth. So, we don't know um, all of the mechanics that go into the creation of life, but if bacterial life existed on Earth at that time and the conditions were similar on Mars, then the thought is bacterial life may exist on Mars. So, you know, MSL, the Mars Science Laboratory, its mission was to see if Mars was once habitable, as we understand habitable for life. And the answer was, yeah, yeah. Once upon a time, there was surface water on Mars. And, it had this primordial environment. So, given that that's the case, we only have Earth as an example of something that creates, life, the conditions that lead to life. But if conditions were similar on another planet, Mars in this case, could Mars also have had life? Now, at the time, both planets were bombarded by, many, you know, a lot of material from space. Um, so there are cases where they have found chunks, small chunks of Martian crust in Antarctica. And how did it wind up in Antarctica? It's an excellent sample return mission all on its own. But something hit Mars once upon a time and sent a bunch of material up into space. And some of that material ended up re-entering on Earth and becoming found as meteorites. So, kind of an interesting thought is if there was life on both planets, if there could have been cross-seeding between the planets. There's some bacteria that can actually be frozen in space and, exist in the environment of space and then come back down and still be viable, which is just amazing to me. I mean, where what's the evolutionary pressure in order to create those types of capabilities for those organisms? And perhaps it was in those initial times where everything was just so chaotic and so tumultuous that things would get like thrown up into space, and mass extinctions would happen on Earth, and then debris would rain down from the skies, and life would be reseeded on the planet again. But I'm waxing a little poetic because there's so much we don't understand that we're still learning about how life evolved on Earth. So here comes 2020. What does 2020 do? 2020 is saying, like, okay, so we've answered the question of habitability. Now, let's go to a place which has terrain that is that old. This is terrain that, comes from the time of that primordial Mars. And, given that, because, signs of life can end up becoming decayed over time. Because remember, this is like 3.5, 4 billion years ago. and you just have radiation from the sun beating on those potential samples. Well, um, what's awesome is that if you go to a cliff face on Mars, you know, certain places with a lot of vertical terrain, and that terrain has been slowly worn away over the last several billion years, then you can have samples in the cliff face that have been exposed um, to the radiation for only a few million years. So it's like, oh wow, fresh. But yeah, fresh. Um, and so we are going to look where we think life might have been if things were similar and evolved similar to your Earth in this primordial environment. Let's go to places where life might have been, where we see from orbit when light bounces off of something on different minerals, based off of the spectra that comes back, we can say like, oh, the surface has this type of material or that type of material or probably that. And so we can say like, okay, we see a couple of materials there that if there were fossils of life, they would have been better preserved. And so, and I mean, I can talk about the site selection process, but let's go to those places with those cliff faces actually. You know, I'll show a picture sometime, but Jezero, take a look for it, but Jezero crater has an ancient river delta. You can see it. You can see the ancient river that broke through the wall of the crater and created a delta. It makes me think of the Nile Delta. And so one awesome thing about a river or a water basin, you know, like where all the places where the water would drain into the river and then come through to the delta, is it's a great concentrator. If there was any bacteria or signs of life, it would have drifted its way into the river and then been concentrated at the river delta and then come through at different layers, which is going to be awesome. So 2020 is going to this place with this delta. I can drive up this cliff because the lake that the delta fed into is gone. But what's left is this delta about 80 meters high, where we can drive up and sample from different strata in that period of time where life might have existed if things were similar to Earth. And we have enough instruments with us because, you know, when you're talking about taking something to Mars, I mean, weight is a premium. So we're able to bring enough instruments to convince ourselves that we probably have an interesting sample or a good sample. But something as big as saying we have evidence of life on Mars. That's a huge bar, right? So we wouldn't trust the instruments that we could bring with us with so weighty a statement. We trust the instruments enough to say like, that's a really compelling sample. I want to know more about that. So this mission will take these samples from this fascinating, compelling area and then have a cache of samples that it stores on the ground. And the next mission, there will be a follow-on mission, a sample return mission, and its goal will be make its way to the sample cache, gather the tubes that were sampled, and then start the journey back to Earth. So once we get them back to Earth, we can subject these samples to like the building-sized instruments, where we can have like that many significant digits, to really convince ourselves that what we have in front of us is or is not evidence of life, past life. We're not going to the places on Mars where Earth bacteria might exist. Well, sorry, that Earth bacteria might thrive today. There are certain places on Mars where the atmosphere is thick enough and it might be warm enough, that if we carried some bacteria on the lander, that bacteria might thrive. And so we're not going to those places. We're going to places where we think that fossils might exist, and then bringing them back home. And so that's why we're going to Mars for 2020. Okay.